And now it's an honor to introduce our first speaker to kick off our program this morning. Stephen Koonin is a national respected leader in science policy. He served as Undersecretary for Science in the U.S. Department of Energy under President Obama, where he was the lead author of the department's strategic plan. With more than 200 peer-reviewed papers in the fields of physics and astrophysics, energy technology, energy policy, and climate science, Dr. Koonin was a professor in climate science. Dr. Koonin was a professor of theoretical physics at Caltech and also served as Caltech's vice president and provost for almost a decade. He is currently a professor at New York University. And in a review of Dr. Koonin's book, Unsettled, What Climate Science Tells Us, What It Doesn't, and Why It Matters, a professor of global energy at the Harvard Kennedy School wrote, Dr. Koonin's book is essential reading and a timely breath of fresh air for climate policy. The science of climate is neither settled nor sufficient to dictate policy. Rather than an existential crisis, we face a wicked problem that requires a pragmatic balancing of costs and benefits. Following his remarks this morning, Dr. Koonin will be joined on stage by Jackie Pick-Deason, radio and podcast host who covers all things energy on the Jackie Daily Show. Jackie will select your questions to ask Dr. Koonin, so be sure to submit your questions using the QR code, which you will find on the cards on your tables. Let's give a warm Steamboat welcome to Dr. Stephen Koonin.
Lately, some of my kinfolk have disowned a few others than me. I guess it's because I kind of changed my direction. Lord, I guess I went and broke their
Thank you.
family tradition.
It's a great choice of music. Well, it has been an adventure to be speaking the truth about climate and energy over the last couple years, and I would like to tell you a little bit about that. I've chosen for my title Unsettling Climate and Energy, and it's actually a triple entendre. Unsettled refers to some crucial points in climate science. It also refers to perhaps you'll feel, as I did, when you hear about some of them that are contrary to what you hear in the popular and political dialogue. And finally, I would say that what we all, nationally and globally, do about the situation remains quite unsettled and the subject of great debate. Climate and energy are certainly at the forefront of the discussion today. I show you here changes in the globe's average surface temperature from about 1880 up to the present. And you can see it starting in about 1900. It's gone up by about 1.1 degrees Celsius. At the same time, we see human influences on the climate growing, largely through the accumulation of carbon dioxide in the atmosphere. And here I show you the measured carbon dioxide from about 1960, and it's going up. It started at 300 and whatever on the graph and is currently about 420 parts per million. We know that that increase is due largely to the burning of fossil fuels as we produce energy that the world needs. But you can also see that the relationship is not so simple, because from 1940 to 1970, the temperature actually went down even as human influences grew. And so the scientific story is a little more complex. What we'd like to know is how will changes in the climate in the future influence ecosystems and human society? And of course, the bottom line question is, what are we going to do about it? Answering that last question means we have to strike a balance. On the one side, we have the science with its certainties and uncertainties, and we have the hazards and risks as the climate changes. On the other side, we've got a growing demand for energy, reliable and affordable and clean, namely with low greenhouse gas emissions. And then in the middle, we've got a set of considerations of values, priorities, society's tolerance for risk, equity between generations and between North-South or developed and developing world. And then finally, we've got, if we think about different responses, are they really going to make a difference, and how much are they going to cost? And I want to take you through these three elements: the science on the left side, the demand on the right side, and some discussion of the responses in the middle as I go through the next 30 minutes or so. So that montage that opened up the session this morning was just wonderful. Right? And you got a sense of how the political sphere or the non-experts think about the science. President Biden, on the first day of his administration, signed an executive order saying we're going to follow the science. Special Envoy Kerry, even back in 2014, said there shouldn't be any doubt in anybody's mind that the science is absolutely certain. And if you can parse the rest of that sentence, I'd like to hear it, because it's something, never mind. All right. And then there are all kinds of other folks who use the phrase existential threat, climate crisis, climate emergency, climate disaster, and so on. The President, Kerry, Senator Sanders, Mark Carney, a major figure in international finance, Bill Gates, my good friend Ernie Moniz. The last two should know better because they're scientists. But nevertheless, you hear those words from them. When the most recent UN report on climate science was released in August, the UN Secretary General Guterres said it's code red for humanity, despite the fact that you can only find the words climate crisis in there once, and that's not a scientific finding, but it's a description of how the US media have over-exaggerated the situation. And then Lloyd Austin, the current Secretary of Defense, has declared it an existential threat. Of course, this was almost a year ago. I think he's got a better sense now of what an existential threat really is. Well, where does the science come from, as opposed to the science? The science gets assessed annually. The science gets assessed by the UN in a series of reports, roughly once every 7 years. The last report was in 2013 or 2014 by the UN. They just issued the next such report on the science and on the impacts. The science report was issued on August 9th, and the impacts report was issued about a month ago. And then we have the US government issuing reports once every 4 years. The last one came out in 2017 and 2018. These reports are meant to survey, assess, and summarize the science as it appears in the literature, the research literature, for non-experts and for decision makers. The reports say important and surprising things when you read them, as I have, and many scientists have. However, most of the people on the slide I just showed you and appeared in the montage have not read those reports. I guarantee you that. Otherwise, they wouldn't be saying the things that they are saying, at least if they're honest. I'm often reminded of a scene from the movie The Princess Bride. Vizzini, one of the characters, the bald guy on the right there, keeps using the word inconceivable. And Inigo Montoya at some point gets so annoyed with him, he says, "You keep using that word, I do not think it means what you think it means." All right? I don't think the science says what most people think it says. And that's on the basis of the reports, not something I'm making up. And in fact, when you read them, you realize that the climate is not broken, and that if we do not face certain disaster unless we take rapid and sweeping action, all right? There is very little justification for that, and in the end, it's going to be a balancing act, as I'll try to elucidate. You might ask, how did the science, which is good, legitimate science, as solid or unsolid as any other, gets turned into the certain science that people talk about, and it's a long game of telephone. It starts from the observational data and the primary research literature. It goes into the assessment reports by the UN and the US government. It goes into the summaries for policymakers of those assessment reports, which are often not in agreement with what's actually in the report itself, in part because they're not written by scientists. Then it goes on to the media, and then out to the public and the decision makers. And along this game of telephone, there's much bad behavior as one goes down the chain. People confuse weather with climate. They highlight recent trends without a historical context. They term implausible scenarios for future emissions as business as usual. There are alarming predictions that never materialize. You can read the list yourself. And when I started to watch this closely about 4 years ago, I decided to write a book, Unsettled, which tries to get around this chain and give people a sense of what the reports actually say. In one of the best introductions that I've had over the last year, I was likened to William Tyndall. Now, I didn't know who William Tyndall was. I'm not a historian. So I discovered he was a guy in the early 16th century who was the first to translate the Bible from the original Greek and Hebrew into English. And it was the forerunner of the King James Version. And needless to say, he annoyed a lot of people when he did that. Made the Bible evident to less educated folks. He was burned at the stake for that, among other things. I've been called a denier, which is not quite as bad, but we'll see what happens. Let me show you a little bit of some of the surprises in the science. There's very little happening with hurricanes over the past almost century. This is a graph of the number of hurricanes and tropical storms since 1970, so it's 50 years. And you can see it goes up and down, but it's certainly not increasing. There's another measure of hurricane activity, which counts the stronger storms more heavily than the weaker storms, and you can see there are ups and downs, both globally and in the Northern Hemisphere, but again, no long-term trend over 50 years. And in fact, the literature says that. Even the assessment reports say that. The US government report in 2018 said there's still low confidence that any reported trend over decades to centuries is robust. There was a landmark paper of 11 authors that gave their individual opinions anonymously in 2019, and what they said was most of the author team has low confidence that there's any other observed trend apart from a slow drift in the Northwest Pacific that can be detected or attributed to human influences. And then the most recent report from the UN in August said there's low confidence in most reported trends over decades to a century in measures of hurricanes that count the frequency or the intensity. There's a little bit of a footnote in there, which I'm happy to go into in the questions, that they think they have seen a slight strengthening of storms, or the fraction of major storms has increased a bit, but it's pretty controversial, and I can elaborate on that if anybody has a question. Let me turn to sea level rise. You often hear sea levels rising. Well, if you don't know anything about geology, that would sound alarming. But in fact, sea level has been rising for 20,000 years. This is the record of sea level rise over about 20,000 years, and you can see it's gone up by about 120 meters. It's 400 feet in 20,000 years. Coastlines were very different 20,000 years ago. Of course, it has slowed down, as you see, starting about 8,000 years ago, but it's still rising. And the real question then is not whether the sea level is rising, but has it accelerated since human influences became significant, let's say since 1900? And the discussion hinges on tenths of a millimeter per year differences in how fast it's rising. We'd like to know whether the acceleration is due to humans at all, and of course, what's going to happen in the next century or two. Well, let me show you, since I live in New York City part of the time, We have really good data for the tide gauge at the tip of Manhattan, the southern tip of Manhattan, which is called the Battery, if you don't know, because there used to be an artillery battery there. And this is the rate of rise as observed from 1920 up until last month. Namely, it's how fast did the sea go up each year. And you can see that on average, it's looking like about 3 millimeters a year. That's a foot a century, not something to get too alarmed about. But interestingly, it goes up and down. And you can see in some years, it was down at less than 2 millimeters a year, in other years up at 5, and it's currently high at 5. And it's thought that these have got to do with long-term cycles of ocean currents in the North Atlantic. Well, NOAA, the National Ocean and Atmospheric Administration, a couple weeks ago issued a report saying that sea level rise for the next 30 years was locked in at 1 foot over the next 30 years. Locked in means it's going to happen no matter what. If that were true, it would take this graph up to where the star is in 30 years. Okay, now, who am I to dispute NOAA, all right? But we're going to find out pretty quickly whether it's going to go up that rapidly or not. Obviously, if it does, we should be thinking differently, perhaps, than we're thinking now. On the other hand, here's a statement from a paper published by Hannah Nissan and collaborators at Columbia University, certainly within the mainstream, that says the use of the models that are used to make these projections to guide adaptation actions is unwarranted. Climate models can't reproduce future conditions with anywhere near the degree of accuracy or precision which will make it useful. Nevertheless, NASA, the IPCC, put out these projections with great confidence. All right, we shall see. Let me turn to weather extremes a bit. A lot in the media over the last summer. Historic heat waves in the Northwest, virtually impossible without human-caused changes, said CNN. European floods were invoked, the latest sign of global warming, the climate connection behind deadly downpours around the world, fires, floods, dead fish, climate change fuels extreme weather with no return to normal, said the New York Times, and maybe the best one from the Boston Globe. Welcome to the climate apocalypse. It's going to get worse. Well, I want to talk about extremes and a reminder that climate plays out over decades. And to do that, I want to talk about denial. Not climate denial, but the Nile River. All right. So there's a map of Cairo, and in the middle of Cairo, in the middle of the river, is Rhode Island. And at the southern tip of Rhode Island, the medieval Egyptians built a structure called a Nilometer, where they measured the height of the Nile River. It was very important to them, as you might imagine. Crops, taxes for whoever was ruling Egypt at the time. That's what the building looks like today. I was fortunate to have visited it about 20 years ago. And if you go inside the building, you see this big vertical chamber with 3 outlets to the river at various levels, and a pillar in the middle suspended from a beam. The pillar is marked in cubits. And of course, we can change cubits into meters. And so a number of people over the century have compiled a record of the readings of the Nilometer, the height of the Nile. This is one such record. It shows the annual minimum that the Nile reached in any year. This is a pretty good measure of climate over about 10% of Africa, which is an area of about 1/3 the continental US. So think Mississippi scale measure of the hydroclimate in Africa. And you can see this record starts in 640 roughly and goes up to 14 something. Year by year, the annual minimum of the Nile. It's great that we have this. And it's really interesting because, first of all, you see there are a lot of ups and downs every year. Some years can be up high at 5.5 meters, and then a year or two later, you're down at 1 meter. So a lot of variability. The second is, if you take an average, climate is defined as a 30-year average, you get the red curve. And what's remarkable about that is, in fact, it still shows a lot of variation. And what you can imagine is that there was some medieval Egyptian climate panel in the 7th and 8th century screaming, new normal, we got to do more prayers and sacrifices. And if they had just waited a couple decades or more, it would have come back up and then even higher. And we're still doing this today. It turns out that the height of the Nile in the minimum is controlled by the level of waters in Lake Victoria. And in 2006, NASA publishes a press release that says Lake Victoria's falling waters. And then last year, there was a press release, Lake Victoria's rising waters. All right? I want to do one more to show you just how misleading the media are on this. And this is about Greenland's losing ice. Okay. Greenland has been losing ice faster and faster for the last 30 years. And there's an article from The Guardian, okay, in December 2019, wonderful picture of somewhere in the Arctic, I assume it's Greenland, and they say the rate of ice loss has risen from 33 billion tons a year in the 90s to 254 billion tons a year in the past decade. Wow, that's pretty scary, right? It's going up and up. Well, I was able to publish in the Wall Street Journal about a month ago the complete graph of how much ice Greenland loses every year. And you can see, well, yeah, it's gone up a lot since 1990, but it also went up from 1920 up to 1940 by the same amount. And human influences were less than a fifth of what they are today back 80 years ago. And then it goes down. And so this has got hardly anything to do with a globe warming under human influences. It's just cycles of weather that extend over decades in the North Atlantic. Nevertheless, The Guardian emphasizes this. Most media coverage does. When I published this graph, I got a lot of grief from people who wrote to the Wall Street Journal, but I was just showing them the data. That's very disturbing. Very disturbing. There's no record trend, there's no clear trend of record high temperatures in the US Northwest, where we had a tremendous heat wave last summer. This shows the number of record highs in a number of stations in the US, starting basically over the last 100 years, both for the US, the black lines, and for the 26 stations in the Pacific Northwest, and there's no trend. What happened was just weather. If you saw the same thing happen 5 years out of the next 10, then you can start to talk about climate, but we're not there yet. But I want to do one more on impacts, and then I want to get on to solutions. Let's see how we're doing on time. Okay, good. Talk about the economic impact of warming. In some ways, this is one of the bottom lines. And a US government report, allegedly the best advice from the best scientists in the country. In the absence of reduction of emissions, climate change is going to impose substantial damages on the US economy that could grow to hundreds of billions of dollars by the end of the century. Okay? And to back that up, they give us this wonderfully interesting chart that shows how much damages would we see under high emission scenario in various sectors of the economy in 2090, essentially the end of the century, versus if we could reduce emissions, how much would we save? And this chart is remarkable for several reasons. One is the numbers are given to 3 significant digits. It's 155 billion 70 years from now, not 153 and not 157, but 155. All right. Second is the degree of granularity. Look, we go all the way down to 300 million in municipal and industrial water supply. How can you say that 70 years from now? And finally, they don't give you any baseline. So for example, the labor sector today must be $5, $6, $7 trillion at least, and 155 billion 70 years hence is kind of small potatoes, all right? Never mind the uncertainty. Nevertheless, the media, when this came out, were all over themselves. Climate change will wallop the US economy. Climate report warns of grim economic consequences. Climate change will cost the US billions. Climate report warns of damaged environment and shrinking economy, right? If you don't read the report, this sounds pretty bad. Here's a graph. This is the last graph in the report in the last chapter, and it shows, for temperature rises in 2090 of up to 9 degrees Fahrenheit, which is 5 centigrade, we got a few percent, 4% damages in 2090. There's a similar graph that Bjorn Lomborg put together. Bjorn is an expert on this stuff, and I'm sure he'll have something more to say about it when he talks at lunch. This is for the globe. The lesson is a few percent for a few degrees. The IPCC knew that that's the case. They wrote, for most economic sectors in their 2015 report, the impact of climate change will be small relative to the impacts of other drivers. All right? In other words, climate change is only one relatively small factor: technology, demographics, governance, trade, et cetera, et cetera. And here's what it looks like. If you look at the US economy, growing at 2%, which is about what the Fed and everybody else thinks it will do. We start here today, and you get the blue curve. If there's a 4% climate impact in 2090, you get the orange curve. Namely, things get delayed by a couple years of growth. And so I would love to share a stage with Bill Gates or Ernie Moniz and ask them, is this what you mean by the climate crisis? It's kind of a bump in the road. The most recent UN report, which came out about a month ago, backed off a little bit and said the aggregate economic impact could be higher than what we said in the previous report, but we have no confidence in that statement. And we can go into the details of that, or Bjorn can, even better than I. All right, let me talk about a response now. What do we do about all of this? So there are global greenhouse gas emissions, and they're going up at a few percent a year, more and more. And if we're going to try to just stabilize human emissions at a level that some people deem to be prudent, we have to go to zero emissions. We need to take this curve down by 2050. And the UN has said, well, this will avoid the worst effects of climate change, which is kind of a meaningless statement because you don't know how bad it's going to be, really. At least the economics doesn't look so bad. And they map out for us various pathways of what it would take in order to do that versus the trajectory that we're currently on, which is this brown line over here. The UN has convened a series of conferences over the last 25 or 30 years. The most recent one happened in Glasgow. It was called COP26, Conference of Parties 26. And my takeaway from that is that the fundamentals of the situation, which have long been evident to anybody who's bothered to study it, as they became to me maybe 15 years ago as I started to learn about this, they have become apparent to everybody. And the way I would summarize the situation is that. Right? So there's Wile E. Coyote. He's been chasing after Roadrunner, and he's found himself off of a cliff. And what's more interesting is the look at his eyes. He suddenly realized that there are some fundamentals in his situation which are going to spell a really bad outcome. Right? And that's what's happening here, and I want to tell you about some of those fundamentals. We'll start with demographics. People, demographics is destiny, right? This is a graph of the historic and projected population of the globe, starting in 1950 and out to 2050. And we're currently just under 8 billion people, and we will grow most middle-of-the-road projections to about 9 billion people by the middle of the century, 30 years from now. And as you can see, most of that growth has happened in Asia. There's some at the bottom of the graph in Africa as well, but Asia is what really opens up, and the rest of the world is pretty static, modest growth. So that's demographics. The second is development. This is a complicated chart. It shows the energy use per capita against the GDP per capita for a number of different countries, year by year since, when did this start? 1980 up until 2017. And while there's a lot to learn by studying this chart in detail, the broad lessons are pretty simple. One is that rich people use more energy, or more well-off people use more energy. Second, there's a big swath of countries up here, including the US, which is over here, Europe over here, whose energy use per capita is relatively constant. The problem is there's only about 1.5 billion people over here. There's another about 6 billion people down here whose energy use is going to increase monotonically as they improve their lot. And so you can put those two things together, population and development, and also realize that fossil fuels have remained predominant in supplying the world's energy, currently about 80% from coal, oil, and gas. Wind and solar, while they're growing rapidly, are down here. Fossil fuels are the most reliable and convenient way of getting energy. You put that together, and you can project that the world's energy consumption is going to grow by 50% from where it is today over the next 30 years. Most of that growth is in Asia. And that if we don't change our policies, the great majority of that energy will continue to be supplied by oil, gas, and coal. These are fundamentals. They're just data. Okay, there's some projections as well, but the basic outlines of the situation are pretty self-evident. And so let's look at the developed world, where we're all living. As I said, 1.5 billion people. Energy is crucial, and it's ubiquitous. It's everywhere. It is what makes society go. It's also provided by complex systems, whether it's the grid or the fuel supply chain for oil. These systems have to be highly reliable, and they are made highly reliable by having proven hardware and proven operating procedures. You don't change them rapidly. In fact, energy systems change slowly for exactly that reason. This shows the US energy supply over the last many decades, maybe a century or so. And you can see coal got added to by oil, got added to by gas. Wood is only a little bit down at the bottom. And recently, we've seen an uptick in renewables. The reason energy systems change slowly, again, is it's big capital expense, long lifetime. Things have to work together. You can't change cars unless you also change the fuel and you change the way in which you deliver the fuel. So lots of pieces have to change together. People say, well, what about efficiency? But there is a phenomenon that's called rebound, which says if I make something more efficient, people will use more of it. And there's some debate about how important that is, but it does, in fact, weaken the impact of efficiency measures. Finally, changes are going to be disruptive. We're going to see changes in economics, employment, behavior, geopolitics, and large and rapid changes will be very disruptive. I like to say you need to change energy systems by orthodontia, not by tooth extraction. Slow, steady change. All right, the Biden administration's plans and goals to reduce emissions, real quick. The goal is to reduce emissions by 2030, so 7 years, 8 years from now, by 50% relative to 2005, its peak, and to go net zero by 2050, to zero out emissions from the power sector in 13 years from now. They've been coming down, largely because gas has been substituting for coal, but also there's a rise in wind and, to a lesser extent, solar generation. We're going to eliminate gasoline and diesel from the light-duty vehicle fleet. You won't be able to buy, if the policies come to pass, a gasoline or diesel engine by 2035. And I was at a conference ending yesterday where I saw the CEO of Ford say, well, we're not going to stop producing them necessarily, the gasoline engines, but we've established a separate division to do those as opposed to electrification. But the car companies, if you watch the ads, are into this big time. There are restrictions on new oil and gas production, despite what the Secretary of Energy has said recently, and Jen Psaki's claims as well. Many people in the room probably know how difficult it is to get a permit and to get production underway, or to secure financing. I think the most dangerous thing they've been doing is to drive climate risk into all aspects of the financial situation through the SEC and the Fed and so on. But there are 1,800 fossil fuel power plants in the country. And if you want to make them all disappear by 2035, as Robert Rice has said, you need to make 11 of them per month disappear. So let's watch that to see if it really comes to pass. There are 280 million gasoline and diesel-powered vehicles in the country. They all have to go away. So concerns, stranded assets, unreliability of the grid, and we're going to become less energy secure because we're discouraging domestic oil and gas production. So Secretary of Energy was talking on Wednesday. I heard her speak. And for the first time, she reached out to the oil and gas company and said, we need to get you to produce more. But that message has not gotten through to other parts of the government. There's constant jawboning of oil and gas and coal production. So the administration's got to decide what it really wants. It's having a hard time doing that. So I think there's going to be a backlash as these measures start to bite on ordinary consumers. And particularly as people realize that the US is only 13% of global emissions, they're going to be asking, tell me again why we're doing all of this? If the US were to go to zero emissions tomorrow, it would be wiped out by a decade's worth of growth in the developing world. So it's not a solution to the problem. Let me not talk about this because I think Robert will probably talk about this, but we do not have a way today to produce a grid that is simultaneously clean in the sense of low emissions, affordable, namely not much more expensive than we have now, and also reliable. If you put in a lot of wind and solar, that's cheap generating capacity, wonderful, but it's highly unreliable. And if you want to make the grid reliable, the most expensive thing you're paying for is that reliability. Do you want it to be 90% reliable, 99% reliable, 99.9% reliable? And each extra bit of reliability costs more and more. By the way, we're at about 99.9% today. Okay. Talk about the developing world a little bit, and then we'll wrap up. Energy demand, I showed you, is correlated with well-being. Emissions from the rest of the world are growing because fossil fuels are the most convenient and reliable, not necessarily the cheapest, but in fact are the most convenient and reliable way for people to meet that demand. Countries like China and India have a compelling near-term self-interest in getting the energy that they need. They're dealing with the wolf at the door as opposed to having to worry about their cholesterol and something that might happen several decades from now. Right? And who can blame them? Right? And as Alex Epstein has pointed out, it is immoral to deny countries the energy that they need or not pay them to reduce their emissions using more advanced forms of energy that will cost more. And so I think it'll be very interesting. There's going to be a debate after I leave the podium, and it'd be very interesting to see that theme explored, the morality of how do you simultaneously satisfy energy demand and reduce emissions. All right, when I look at all of this, adaptation is going to be the dominant response. That's what the globe is going to do. It's agnostic. It doesn't matter whether the climate is changing for human or natural reasons. It's proportional. You do more if the climate changes more, and you do less if the climate changes less. It's local. Then we would build seawalls, let's say, or shift the kind of crops that we're growing. And so it's politically palatable, as opposed to spending something that's half a world away and maybe a generation away, and does not require global consensus. It's autonomous. It happens on its own. One of the defining human characteristics is our adaptability, and it is effective. Consider that the globe has warmed by 1.1 degrees since 1900. And during that time, we've seen the greatest improvement in human welfare ever. We went from 2 billion people in 1900 to just about 8 now, 4 times. And at the same time, we've seen enormous improvements in the quality of life, nutrition, health, education, and so on. To believe that another 1.1, 1.4 degrees, which is what the UN projects through the end of the century, on average, is going to significantly derail that, I think it beggars belief. On the other hand, adaptation is much easier if you're richer, and it also helps if you know what you're going to adapt to. And beyond general phrases like the globe is going to warm, it's going to warm a little more in the Arctic than in the mid-latitudes, or that sea level is going to rise, but by how much, it's kind of vague, as I showed you in that quote about sea level rise. Let me wrap up with my next to last slide. We must not Gruberize climate science. Now, what do I mean by Gruberize? Well, Jonathan Gruber, who's still a professor at MIT, as an economist, was one of the principal architects of the Affordable Care Act, Obamacare. And whatever you might think about Obamacare, here is something he said after the act was passed and he was back out of the government. The lack of transparency is a huge political advantage. It was really, really critical to getting the Affordable Care Act passed. At least one key provision was a very clever basic exploitation of the lack of economic understanding of the American voter. For an educator and an expert to say that is so wrong. If we misrepresent the science or the potential of various energy technologies, we do great damage when we try to persuade people rather than inform them. We take away their right to make informed decisions because, after all, as I showed you, this is a values discussion in the end. It distracts from more urgent needs, and certainly of the last couple years, we've seen a couple of more urgent needs than something that's going to happen 30 or 50 years from now. We tarnish the reputation of science as it makes input into other matters, like pandemics. And maybe most depressingly, we have depressed young people. We've scared the bejesus out of them. And that is just so wrong. And that's one of the reasons I wrote the book. All right, last slide. What do I think we should do going forward? We should cancel the climate crisis. Okay, there is no justification for saying we have a crisis. But at the same time, we should acknowledge the task and the challenge of trying to reduce human influences. We need to better represent the science and energy. Energy and climate literacy are so important and so deficient among the general public. I would also advocate, as I had in the past, a red team review of the reports to make sure that they don't have the errors and misleading sections that are in the current reports. We got to keep watching the climate. If nothing else, this is a data-driven science. We really need to know what it's doing, and we need to do it continuously and with high precision. I would put a greater focus on adaptation. Right now, we don't have a good framework for it or a good estimate of the costs. And in the developing countries, we need to simply promote their development and their resilience. You need to be able to execute national strategies. You need to be able to be wealthy enough to do the adaptation. I'm all in favor of developing and demonstrating emissions-light technologies. My favorites are small modular fission reactors, large-scale grid storage, batteries, non-carbon chemical fuels, all great, but none of them are really ready for prime time, particularly if your criterion is that it shouldn't cost much more than the current way we have of doing business. Then I think maybe most importantly, I would formulate a graceful decarbonization pathway. Bjorn Lomborg has taught me that Bill Nordhaus, who won the Nobel Prize in 2018, realized that there's an optimal pace for decarbonization that balances disruption against doing it too rapidly, against growing risk of something bad happening with the climate. And so we need to find out what that optimum is and put together a plan that incorporates technology, business, economics, regulation, behavior, and then implement it as necessary depending upon what we see the climate doing. I'll close with the thought that precipitous climate action is a far greater danger to the nation's and the globe's well-being than is anything we can imagine for climate change. And with that, thanks for your attention, and I'm happy to take questions or comments.
Now we'll welcome to the stage Jackie Pick-Deason. Jackie is host of the podcast, The Jackie Daily Show. You need to listen to this. It's all things energy. Find it wherever you find podcasts. And welcome, Jackie. And now submit your questions using the code that was texted to you.
Good to see you again, Dr. Koonin.
Great to be
with all of you and here in Colorado. So I have a lot of questions that have been fed in during your presentation. We'll take them one by one.
Okay.
So the first, how did you land a job in the Obama administration, given your independent views on climate change?
Well, look, you know, one's views evolve as one learns more and as the science and the technology evolves. I joined BP in 2004 to help them figure out what beyond petroleum was. They didn't need me to help them find oil and gas. They were very good at doing that already. And so I educated myself about energy and energy technologies with the goal of helping to develop or catalyze the development of low-emission technologies. I wasn't very focused on the science at the time, had not looked deeply at it. And I did more or less the same thing in the Obama administration. But in 2013, or 2014, early 2014, I had a hard look at the science at the behest of the American Physical Society. It's recounted in the book, if people are interested in the details. And I started to realize this is not as solid as people think it is. The political dialogue became more and more hyperbolic. The proposed energy solutions became more and more unrealistic after 2014. And then I finally decided, okay, I've got to speak out in a more significant way than just writing op-ed columns, and so write the book.
Okay, so this is a question I'm giving to you, not mine. Dr. Koonin, you come from the political left, which increasingly espouses the catastrophic narrative. On the right, many still believe it is a Chinese hoax. Do you see any prospect of the realistic viewpoint gaining traction in the political realm?
First of all, with respect to my own political affiliations, I have never registered as a member of any party. I've always been independent. I did, of course, serve in the Obama administration. But my view of what scientists should be doing in the political realm is provide advice, analysis, options, but not make the decisions. And I've tried to do that when I was in the private sector and when I was in the government. I think it's best if we try to stay apolitical, as does the military and the judiciary. Many of my colleagues don't subscribe to that, unfortunately. When you get politicians, industry leaders in a closed room with an honest discussion, it's a very different kind of conversation than what you see in public. That's all I'll say.
Okay. So you mentioned the public reaction that could be quite strong. How soon do you see that coming on?
Well, you know, the whole climate agenda has now taken a back seat, given what's happened in Ukraine and what's happened with the energy system, Ukraine. I think people have come to realize just how important a secure, reliable, affordable energy supply is. And I think that's going to color a lot of the thinking going forward. I think we're going to start to see it already at the midterm elections, and certainly by the 2024 elections.
Okay. Science question. What do most climate models assume about cloud feedback? How likely is that those assumptions are correct? And what does it mean for forecasting if they're wrong?
Yeah.
And can you first define cloud feedback?
Yeah, so cloud feedback first, okay. So cloud feedback happens in different ways. It's the way in which clouds change in response to a warming globe, which then affects the warming itself. Let me give you a simple example. If the temperature of the atmosphere goes up, it can hold a little bit more water. You would think that that might make for more clouds. Clouds help reflect sunlight, and so that would be a negative feedback in the sense that the increased clouds would make it a little bit cooler than it would have been otherwise. The high clouds have the opposite effect, and getting the balance right is complicated. But the problem with clouds in the models is the following. The climate models cut the Earth, the atmosphere, and the ocean into boxes, and the boxes are typically 60 miles on a side. So you only have one number to describe the conditions in each of those millions of boxes. The one number might be the temperature, maybe the humidity, that's it, but not the variation across the box. And unfortunately, clouds occur on much smaller spatial scales. Cloud can be a couple miles across, whereas the box is 60 miles across. And so you're going to have to make assumptions about what clouds are doing, altitude, type, amount, depending upon just the average over the box. And people try to do the best that they can. They use observations, they use physical principles, but in the end, these so-called subgrid parameterizations of clouds are one of the biggest uncertainties in the models. Different people make different assumptions, and because we're looking at such small changes, you can get almost any answer you want. But I think it's generally acknowledged that the lack of doing good cloud parameterizations is one of the big problems in the models.
Okay. Why do you recommend decarbonization when there is no detectable anthropogenic signal in the climate, and we know from the available data that both increasing CO2 in the atmosphere and warmer weather at high latitudes will save lives, increase biodiversity, and increase well-being?
Okay, so those are two different questions. Let me talk about the anthropogenic signal first. I think there are anthropogenic signals, maybe not in the gross climate, but in the details of the radiation flow, the temperature in the upper atmosphere, and so on. These are, with good physical reason, changed by growing amounts of CO2, and that's certainly going to have some effect on the climate. The problem is, these are physically small effects. Human influences on the climate amount today to about 2 watts per square meter, whereas the overall flows in the energy system are 200 or 300 watts per square meter. So the human influences today are about a 1% effect. And you can say, well, why do I care about 1%? The problem is the climate is also sensitive. A rise of 2 or 3 degrees in the surface temperature is a 1% rise in the temperature. And so it's sensitive, the effects are small, and there are many other phenomena that can influence the climate at that level. Natural variability, which I showed you in several cases, is one of them. So untangling all of that is a difficult business. Yet I think most people would say some fraction of the warming of the last decades, whether it's 100% as the UN says, or it's closer to 50% as I believe, and we can again go into some of the details, it's still up for grabs. The second question is whether the warming is good or bad, and I think that depends on where you sit. You know, there's a lovely quote from a guy named Anthony Downs. He was a political scientist, social scientist, working in the 1970s. And he was a He worked at Brookings, so he was on the left. And he wrote a wonderful paper called Up and Down with Ecology, working mostly, or talking mostly, about local pollution from smog. He was worried about the growing number of vehicles and so on. I think he was in Los Angeles at the time he wrote it. And he has this great quote. It says that the elite's environmental deterioration is often the common man's improving his standard of living. And so he was worried about the proliferation of automobiles to everybody. We've got the same situation now with the developed versus developing countries. I don't know whether it's good or bad, all right? It'd probably be okay to not do it if other things were equal, but the problem is other things are not equal.
Okay. Can you speak to the Atlantic conveyor belt slowing? How much history do we have on it, enough to draw conclusions? And I would say, can you please define Atlantic conveyor belt slowing?
Yeah. So one of the major features of the Earth's climate system, an important one, is the warming of waters in the northern tropical Atlantic, above there, the creation of the Gulf Stream, which carries a lot of heat from the equator to the poles, and then the sinking of that water as it becomes colder and more saline. It goes down to the bottom, flows down under the Atlantic in a slow current, centimeters per, I can't remember. It takes 1,000 years for it to go the whole way around. Goes down past South America, shows up in the Indian Ocean and so on. This is the great conveyor belt. Wally Broker was the guy who discovered it in the 80s, I think. The concern is that, well, maybe it's going to slow down a little and hence not carry heat as rapidly from the equator to the poles, make for a colder northern hemisphere and so on. Well, is it going to get colder or warmer? That's the first question. The second question is, what do we know about it? It's kind of hard to measure. There have been papers that have been measured over the last couple decades that see it slowing down somewhat. Is that human caused? Or, you know, remember the Nile, all right? It goes up and down and up and down. I don't think we know.
Okay, the build-out of temperature measurement in urban, or the spread of urban areas affecting temperature models, do you think that is a real concern or not?
No, I'm not so concerned about that. So again, for people who may not be so up on it, when you measure the temperature in a city, it's a few degrees warmer than the surrounding countryside. You see that on the weather report every day. That's called the urban heat island. And it's a real phenomenon. And some people got concerned that the record of global temperature, which I showed you at the beginning, was being contaminated by the growth of urban regions, making it warm more rapidly than it should have been. I've got to say that the people who compile the surface temperature record from weather data, I believe, do a pretty careful job. There are 4 or 5 independent estimates doing that. One of them, the most recent one, is led by my good friend Rich Muller, called the Berkeley Earth Analysis. I helped get that program started when I was in the Department of Energy. I don't find much to criticize in the way that's been done. Yes, people look at isolated stations. Anthony Watson collaborators have shown you pictures of weather stations that are in locations that would make your hair raise. They're next to an air conditioner event, or they've been moved from a grass area onto a concrete and so on. But I think people try to take that into account pretty well.
Okay. We have time for one more. What about the rest of the world building 400 to 500 coal electric plants and coal mines? Why should we spend money on decarbonizing while they ramp up, making our money or our energy more expensive, shifting more jobs and economic activity to them while they enjoy the lower energy cost?
So I don't have an answer to that, all right? I think that's going outside of my remit as a scientist. I might have personal opinion about that, but it's not worth much. It's probably worth less than the average. This is a values issue for society. It is the thing we should be debating, not whether the science is right or wrong. We need an accurate representation of the science, But that's a moral discussion. And I hope that that's the kind of discussion we should be having in our political sphere, not simply, don't you care about your grandchildren? All right?
Okay, so Ms. Aiken says we run on time here. So I believe we are about at the 10 o'clock mark.
Thank you very much.
Okay.
Let's have a great big round of applause. What a great way to start the morning. Thank you, Dr. Koonin. Thank you, Jackie.
Thank you.